Thank you, Dr. Cohen. That was a fascinating talk. Thanks for sharing with us. My question's directed to you, and also the other two speakers might like to jump in. I'm interested in knowing whether you're, as part of this long study, whether you're looking at a woman's individual susceptibility to environmental toxins based on the nutritional status of that woman, e.g. how we can modify the toxicity of environmental chemicals by actually supporting and nourishing our own bodies.
This is a very, very important and very interesting question, and we aren't there yet, and let me tell you why. I didn't talk to you at all about mixtures, but I just, spent, roughly 5 to 10 years looking at one chemical. We're exposed to 80,000 or maybe 90,000 now of these chemicals, and in the blood of my women I can find many, many different chemicals, including things that are related to what she eats, like, for example, vitamin D. And the analysis of mixtures, the scientific methods that are required for us to understand in how these different chemicals, some of them come from inside, some of them come from diet, some of them come from, basically we think of them as environmental contaminants, but we don't really know how they combine to help or harm us. And the research, I wish I could tell you was there, it's not. And one can look at one hypothesis at a time now, 1 or 2 nutrients at a time. Some people have become very interested in vitamin D because it turns out to potentially be, at least in what is called a cross-sectional study, correlated with levels of some of these compounds. But we just don't know, and we don't know which nutrient to test. If we were to test nutrients, which one would we pick? So we don't have the answer yet, but of course that's a place where we'd love to get to, because it isn't only about, predetermined one's destiny, in utero. We have to understand these things in order to understand how to stop the risk, and that's the objective.
Actually, if I could just add something very small, actually very small in terms of number of words, but very big in concept. And I mean, what Barbara was just saying about nutrients is really absolutely true, but it's in many ways, and she knows this better than I do, it's so much bigger, because some of the chemicals you get in your food, they might be natural chemicals in that food, like cabbage, for example, contains a whole load of glycosinolates and a lot of isothiocyanates and many, many chemicals that actually induce certain enzymes in your cells. And when those enzymes are induced, they can actually metabolize some of the foreign chemicals to more toxic versions of those foreign chemicals. So it's not only a combination of the chemicals, it's a combination of the effects that those chemicals have on your body. And some of us have genetic predispositions to metabolizing these chemicals better, which is good normally because it's detoxifying and getting rid of them. But in some circumstances it's bad because it's making toxic chemicals of them. So it's an incredibly diverse, hugely complex melee of chemicals we're exposed to, an incredibly diverse and hugely complex melee of things we can do to them. So to ask Barbara that question was very unfair at 8 o'clock in the evening, whatever time it is, 9 o'clock in the evening, when she should be having a glass of gin and tonic.
No, actually, I'd like to follow up on that. So I want to say that the most consistent findings we have for DDT in this cohort, over and over again, for different subpopulations, for mothers following exposure in pregnancy, for children following exposure in utero, for multiple outcomes, like for testis cancer, for breast cancer in mothers, for time to pregnancy in daughters, at least with respect now to DDT, the risk factor seems to be relative amounts of these, not just 2, but 3 compounds, which makes us think that we are looking at host factors. The problem is, what we can't disentangle is whether the relative levels of these compounds are a marker for something that is a characteristic of the woman, and whether the compound itself has to be present in order for the harm to happen. We do not know. We do not know. And that's just for one chemical that's been banned for 30 years. And so this is a very complex field, and the area of toxicology is the place to go next. The experiments that are being done now side by side with a wonderful young toxicologist are the most exciting things that we're doing, because she can do in animals what we cannot do in people. And we've started doing some work on, this might not interest a breast cancer audience, but on hypertension and metabolic syndrome in our 50-year-old women in relation to this same pesticide, to DDT. And she's doing some mouse experiments side by side with the same internal dose, and she's seeing similar associations with the hallmarks of metabolic syndrome, which is like hypertension, obesity, and diabetes, changes in insulin and glucose. And she's able to take a look at organ damage too, to see what is actually happening internally inside these mice. So it's really exciting to us. You know, I used to have no answer to the question, well, if these studies are so expensive and they take so long, and you're the only one who can talk about this, isn't this a dead end? And the answer is no, it's a beginning.
Thank you.
Barbara, that was a wonderful talk. I enjoyed it a lot, and thank you for that, and also the other speakers today. I just had a quick question. Could you just perhaps go over, clarify for me, your results are DDT versus DDE. DDE, the metabolite. You managed to disentangle the results for the DDT versus DDE, and I think you said the DDE was not so dangerous. Did I get that right, or the effect was not so great?
I went over it really fast. Yeah. No. So when we measured all three, it was the para-para DDT, which is the primary insecticidal ingredient that would have been in the can that you sprayed or in the pest strip that you hung in your kitchen. That was the risk factor. And in fact, higher levels of orthopara DDT were protective, while DDE itself, once you knew the levels of the other two, made no further contribution to risk. Now, this is actually really interesting, because it sort of points out the necessity for, you know, objectivity in science. I didn't start this work because I thought DDT was bad. I knew I had samples that would be very high, had high levels, and so that's why I did the work. But it's very important to report out everything. And so in this case, here you have a compound that might be protective. Very interesting. We need to know why. In follow-up studies in the daughter's generation, studies I didn't talk to you about, we've actually seen a relationship between in utero exposure to this so-called protective type DDT, OP DDT, and earlier age at menopause. I want it to sink in a bit. Early age at menopause is protective for breast cancer, but it's not so good for other things, including the plans of women who plan to have children later in life than earlier. And there are other issues for cardiovascular disease and bone health for the early onset of menopause. And so it's not going to ever be a really simple issue. But it is possible, it's plausible that maybe one reason why OP DDT in those pregnant women was protective for subsequent breast cancer before the age of 50 is that their ovaries shut down earlier and they had lower hormonal exposures over their lifetime. So these are going to be, and that also illustrates why having results in multiple generations can give us more clues. This is the kind of work that, this stuff can get studied in animals, and, you know, maybe we'll go forward and do that, I hope. That work is, you know, in preparation.
Thank you, Barbara. A third question? Someone with a microphone, I need.
This is really for Professor Shaw. Just talking with people, I gathered that the soy versus dairy milk was quite a big deal for people, choosing what they should have themselves and give their children. And I wondered about the hormones that come through in the milk, whether they might be because of something applied to the pasture, or whether it's something that cows make themselves to deliver to their calves via their milk, and whether that's something we should be worried about if we are having dairy products.
Yeah. And I think one thing that we have to say right at the very beginning is you've got to be really careful, and I'm guilty of doing this, and you have to stop me, looking at things from a one-eyed point of view. And today we've been talking about environmental estrogens for part of the time and estrogenic compounds generally, and therefore I've been talking about them from that point of view. So from that point of view, soy milk isn't a particularly good idea because of the very high levels of genistein in it. But from the point of view of other aspects of health, like heart attack, then it is a much better option because it's got less fat in it. So you have to remember those things. It's a very, very big issue. If you look at normal everyday cow's milk, just like normal everyday woman's milk, it contains estrogens because you excrete estrogens in milk and cows excrete estrogens in milk too. So when you drink cow's milk, you're automatically drinking some estrogens. Now, it depends when in the cow's cycle that milk's taken, what levels of estrogens are there. Now, normally in most farming situations in New Zealand, cattle are allowed to have calves every year in order to keep them in milk. In America, they sometimes use BST, an enzyme, but the effect is just the same. It causes increased excretion of estrogens in their milk. So from the point of view of exposure to estrogenic compounds, you are exposed to estrogens from cow's milk as well as estrogenic compounds from soy milk. So from that point of view, it's a sort of, you take your chances. But if you look at the levels that you're exposed to, the levels of estrogenic compounds in soy are greater than the levels of estrogens in cow's milk. But the activity of the estrogenic compounds in soy milk are lower overall than the estrogens in cow's milk. Now, you get to a point where I'm just going to have to rest my case, because if you try and grapple with those numbers, there's just swings and roundabouts all the way through. And my feeling always, and it's not a very good scientific theory or feeling, and I'd be very interested in Charlotte's views on this, is that you're best to err on the side of the natural product, which is the cow's milk, but again, to drink it, eat it, use it as part of a very well-balanced diet, rather than saying I'm going to survive totally on drinking cow's milk or soy milk is going to be a major part of my diet. If it's a component, it's fine, there's no problem. But if you start majoring on it, then there may be more problems, I think. But I'd be really interested in Charlotte's views, because I might be right off the ball there.
Look, I don't really... Ian's the expert on this. The whole question about what's natural is such a vexed one, isn't it? Because you could say that in parts of Asia, actually soy is the natural thing.
Well, we had a conversation about just
this. And we had an epidemic of heart disease in New Zealand in the 50s and 60s because we ate, we had too much dairy and too much butter and too much animal fat, and, natural though they are. So I'm open.
And I think, following on from that point, which is a really important point, you can swing too far the other way when you get concerned about something. And there's an example, not in the breast cancer field, but in the heart disease field, where the New Zealand government got very worried about the increasing incidence of heart attacks, basically, and said, well, thou should not eat so much salt. So we all went away and stopped eating salt, and now we've got an iodine deficiency because we don't eat enough salt. Yes. And we went too far, and now bread makers are being told by the government, under legislation, to put iodized salt into their bread to increase New Zealanders' intake of salt, because we're getting iodine deficiency, which is leading to thyroid cancer. Which is why I keep saying balance, natural, not necessarily natural, balance, broad diet, so that you don't keep swinging from one side to the other. What does Barbara think all the way over in the good old US?
About milk?
About anything?
I'll tell you, milk's very interesting in our cohort. So think 1960, kind of put your 1960 hat on. What did we have in 1960? We had open-air nuclear testing in 1960, and we had monitoring of dairy products in the United States for strontium-90. I mean, this is a really interesting thing to think about, and the reason I think about it is that we had an early study in the Child Health and Development Studies that my predecessor, the second director, reported on, of higher perinatal mortality associated with in women who drank lots and lots of milk in pregnancy. And so the question is, what was in the milk? So what was on the grass goes into the cow, what goes into the cow goes into the child. We really don't know what pesticides and herbicides, whether they were organophosphates. We have no idea what was in the milk supply in California in 1960. And what I think is of great interest to all of us is biomonitoring the food supply is actually going to help us a little bit understand some of these questions. And we're going to do that in California. We have legislation that passed, state-specific legislation to do that. It will help women think about this, and the general population think about this. The other thing is mother's milk. Breastfed infants are receiving chemicals from their mother's milk. There is nobody recommending that there's a better food. And at least you can call that natural, whereas maybe you could argue about soy and cattle. But we know that when a woman lactates, the compounds that are stored in her fat move into her milk. And the compounds, one of the best way for a woman to excrete some of these fat-soluble persistent compounds is to nurse her baby. And so it's not about being alarmist, it's about being informed. It's about having information for us all to make the best decisions we can make. Even scientists don't have what they need to know in order to answer an important question like this.
Thank you, Barbara. Do we have another question?
So I'm thinking about plastic containers, and I think a lot of us know that polycarbonate has BPA in it, and we learned that if it's locked up in a chain, that it isn't a problem to us, but it's when the molecules break free from their chain form that we should worry about it. But what about other plastic containers other than polycarbonate containers? Is there BPA or other plasticizers that we should be worried about? We send our children to school with plastic, non-BPA containing, apparently, bottles, but should we be more extreme in searching for glass or metal alternatives?
Yeah, something I should just say at the very beginning, perhaps I should answer that question, is that I hear, and Barbara will know, that the states just banned BPA babies' bottles. So I said this morning I didn't know what the decision was going to be. I knew they were making it. Well, apparently they've made it. So that was quite an interesting decision that's happened while we've been sitting talking today.
I actually didn't know because I was out of the office for 2 days. So
well,
that's interesting.
It's happened, Barbara. Nobody told me.
No.
How dare they?
No one told me either.
Well, should have
we
told
actually
you.
can.
They should have told
it's
you
really interesting.
Yeah, it is.
We can measure BPA in our serum in 1960. We just found that out.
Oh, that's interesting.
We've done some pilot work, which is amazing. So BPA is a problem, really hard to study. It's not persistent.
No.
So if you combine the necessity to know precisely when the exposure happened, we don't have the same leisure that we have with these persistent chemicals where you can basically take one sample from a woman sometime over a 9-month period and be pretty sure if she was high at that point she would be high on that substance in the first trimester or the second trimester. But BPA, we are unsure. But another example, this question is very important. Many times people will ban one thing, and industry will say, okay, you're right, we aren't going to use that anymore, but then there's a replacement.
Yes.
And
yes.
so,
and it's worse.
And in the United States, we don't ask industry to prove no harm. So it means that it falls on the shoulders of the scientific community to look one substance at a time for what the consequences of the replacement might be. And we're going through that here now in the States regarding flame retardants. Some are being banned because they are highly persistent, clearly very toxic. But they are being replaced by other compounds, and we don't know what the consequence is.
And often the problem is, and I'll answer your question in a minute, often the problem is when you replace a compound with another one, you're replacing it to do the same job, and so it often has very similar properties, which can be
may have shared structure, yeah.
Yeah, exactly. But in answer to the question, with respect to other plastics and whether they might contain things that are equally as bad, if you'd asked me that question 6 years ago, I would have listed a whole load of them. But we're actually slowly removing them, and I'll give you some examples. I've talked to one or two of you over the lunch break and coffee breaks, the large amount of food that we've eaten when I've not been able to eat because you've all been asking me questions, which is very, very sad for me. Yes. But you can see it's worked. There's nothing going on. But just a little while ago, the cling film type things that you use in the kitchen contain dibutyl phthalate. About 35% of the weight of cling film is dibutyl phthalate. And if you wrapped cheese or bacon or something fatty in that cling film, some of the dibutyl phthalate would go into it. And I don't know whether a lot of it actually, I don't know whether you remember that in the old days, not too long ago, 4 or 5 years ago, if you put cling film over something in the microwave, which is a great way to keep the microwave clean, and it was fatty food, that cling film would almost go crinkly, crispy, because it lost its plasticizer, dibutyl phthalate, into the food. And that's why it became crispy. We've now replaced, the world has now replaced dibutyl phthalate with adipic acid in cling film. It's got similar properties, but we don't think, very important word there, it's going to have any effects because it's very rapidly metabolized in the body, very rapidly broken down, very rapidly excreted. So that answers that question, perhaps. Then the polystyrene plastics used to contain non-alphenol, and I showed you the work that we've done on non-alphenol and its structure. That's now been removed. And I got rather interested in that because the little containers that in vitro fertilization is carried out in and the embryo is allowed to grow in are polystyrene. And they had originally had non-alphenol plasticizers, and I was worried about the non-alphenol coming out and affecting the very early stages of development, which might then be promulgated through the later growth and development of that child. They now no longer contain that. So slowly we're removing these things, but we are adding other plasticizers. But as Barbara said, the onus is on the industry to try and produce something that's not going to be a problem. And of course it's in their interest to do that, because it doesn't look too good if they produce nasty things to replace the nasty things they've just removed. So there is quite a lot of goodwill, I think, out in the industry in trying to do this. And they are looking for things that are rapidly degraded in the environment, rapidly degraded in people, so there won't be persistent long-term effects. So in terms of the plastics that we're using now, the risk is going down, and there is no question about that. And if we could just deal with BPA, I think the risk would go down very, very significantly indeed. And the issue with BPA is not the breakdown of the plastic. It's actually the unpolymerized BPA that's sitting there in the plastic. And if it's manufactured very well, there will be very little unpolymerized BPA.
That's interesting.
Thank you. Professor Paul, you had a question?
Barbara, I really enjoyed your talk, and I read your 2007 paper that you talked about DDT and breast cancer. And I guess I had a question for you. So I don't know very much about this area, but I talked a little bit about DES and the recent work that's pretty strongly suggests that DES exposure in utero increases the risk of breast cancer for the daughters, so for the people who are exposed in utero. And I was thinking about your results, and I was wondering whether, if DDT exposure started in, I think, 45, you said, and it increased quite rapidly, and most people were exposed, whether you might, and you show quite strong relative risks, or odds ratios or whatever, for exposure, whether you might even see some sort of cohort effect, that is, women born from, from 45, I think you're not quite sure whether it's in utero or it's in very early life, so that would blur the boundaries a bit, but whether you might expect to see this group from, sort of my generation actually, having an increased risk of breast cancer, some sort of cohort effect, so the group earlier didn't, and then suddenly there was a group with high risk.
That's a really good question, and there's a guy who wrote a comment about our paper that said that there wasn't such a strong birth cohort effect that he could see for early breast cancer. I want to say also, by the way, the work that we've done is just for breast cancer before the age of 50, which is still, thank God, a very rare event. Yep. We are extending the study to up to age 54 now. We're going to see, there's no reason to believe that that we'll get the same outcome. The disease does change, and the way it happens is altered according to the age at which it appears. And so not only is there variation by exposure timing, there's also a variation by outcome timing. We know that already for many different diseases, so it's very complicated. But my answer to your question is, I think we've been really lucky we're all not infertile either. I mean, all this stuff, hanging around, we're still having babies. Even in the worst, nutritional status in the world, in Africa, populations have babies. And I think the question here is, you may see this spike, you may see such a birth cohort effect, but instead what you may really see is a change in who gets sick and who the susceptibles are. And I don't think you have to necessarily see a sort of, I call it an Armageddon scenario in order to postulate a change that has happened to all of us. That I believe biologists tell us that the epigenome changes in order to allow us to adapt very rapidly to environmental challenges, to our ability to reproduce and survive. And so I don't think it's necessary to demonstrate Armageddon in order to demonstrate effects. And so you'd have to have a really pretty strong, terrible, awful, unopposed effect of DDT in order to force a risk of an entire cohort of women to the ceiling. There are other things that may also mitigate risk, and this is going to surprise you, but one of them may be some of the other industrial chemicals that actually act as androgens and actually oppose estrogen in the body, including things like dioxin, which is a very nasty, horrible, awful thing. And perhaps at the right period of exposure, if you're exposed to the right mixture, one eats the other and you're in good shape. And now, I'm not suggesting we should be grateful for these chemical mixtures, but I think we need to be vigilant. I think we need to understand that I believe there's enough evidence to suggest that these exposures are not neutral to very important biological function. That doesn't mean we're all going to die out next week, that every single man on the planet will fail to impregnate their wife. You don't really need Armageddon to make subtle changes. And so, for example, one of the papers that we had, you raised DES, is very interesting. We have the DES triumvirate in our study population with DDT. Right. We have testis cancer in the men. We don't, although we don't have that really with DES, but there were abnormalities in male children. Yeah. We have breast cancer in the mothers, and we have reproductive abnormalities, non-specific, at least alterations in time to pregnancy in the daughters, which could be at any level. We don't know what the mechanism might be, but it could be ovarian, it could be uterine, it could be all kinds of different things. And so one also has to stop and think about, for example, the so-called estrogen hypothesis. DES was a really strong estrogen, but what else was it? Is it also a true toxin, an environmental toxin? It was a pharmaceutical toxin, but it still could be a toxin itself. So I think it's actually a really interesting question, generally speaking. So maybe not Armageddon, but still subtle changes in the way we're developing and changing. We have early puberty now, and we don't exactly understand it, for example. Yeah.
Can I just follow that up with one statement? Yeah, no, I wasn't expecting Armageddon, but I guess it does
remind us.
I don't, just remind us that actually, although these effects are in the past, actually, if it's in utero exposure, they're not potentially completely in the past.
Can I make a comment before we move on DDT in New Zealand? Because something Barbara said when you were talking is, I don't know about DDT in New Zealand, and it might be interesting to tell you very briefly, and the audience might be interested too, that New Zealand had one of the highest exposures to DDT in the world, because we embraced the compound because of grass grub. And grass grub was growing underneath the soil, eating the roots of the grass and stopping our sheep growing. And so we put very large amounts of DDT onto the soil. And then the levels were so high in milk that the food safety, as it is or was until very recently, the Food Safety Authority, and before that the Ministry of Health, actually made some changes in advice they gave to farmers. And farmers in high DDT areas had to measure DDT in the soil, and they couldn't grow dairy cattle on that soil as a way of reducing the human intake of DDT. Wow. And if you look over the last 30 years, intake of DDT, and this is measured every year by the New Zealand Food Safety Authority, some fantastic data on their website. If you go there, you can see, and Barbara can't see me because I'm making a graph now, it's actually going down exponentially. such that now the DDT intake from milk, which was the major source of DDT in the New Zealand diet, is almost, in quotes, non-existent. And that's a very good way of managing risk, because the DDT and its metabolites, DDE, are going to stay there forever in the environment, so you've got to do something else about it, simply because we use so much of it.
You mentioned iodine in the context of health. With estrogen metabolism, have you seen the work on the metabolism of estrogen into the 2-alpha hydroxy and 4 and 16 series, and the influence of iodine on that?
I have, yeah.
Yeah, so I'm just wondering how you feel about it.
Well, I'm kind of intrigued by the whole thing, and I had last week a really exciting few days with a lady called Kate Hill from Massey University. She's a vet, and she's got a colony of cats, and this is the sort of Barbara type cohort, but it's a bit different because these are cats and they breed faster. Barbara, you should come and see our cats. And she's been looking at thyroid cancer in these cats, and she's shown that it's linked to certain things that the cats do and certain foods that they have and certain treatments that they've been given. And you'll see where I'm going in a minute. And one of the treatments, in fact, that appears to be associated with it is treatment with pyrethroid insecticides as a flea treatment. Another is if the cats, there are some publications that are not to do with her cohort of cats, but to do with other cats. If the cats live on farms or drink from puddles, who on earth would measure that? I don't know, but they did. Have got more likelihood of thyroid cancer. And we're sort of hypothesizing a bit, in fact, that the reason for this is that a metabolite, one that one of my PhD students discovered, actually, of the pyrethroids, is estrogenic, but it also mimics thyroxine. And what we're seeing, we think, and we're just starting a joint research project on this, which is why we met, we're seeing some link between what the estrogenic compounds can do and their involvement with the thyroid as well. And I don't know whether you remember, this is a highly complex answer to what was a quite simple question, but the problem is it's a huge issue that you're raising. I showed a slide which I said, don't worry about this too much. It was the glucocorticoid pathway, the metabolic pathways that lead to the production of testosterone on one side and the androgens, and on the other side, the hormones that control glucose metabolism. And some of those hormones are also involved in thyroxine production and metabolism. And if you get a chemical that interferes with the production of one of the enzymes, as the dibutyl phthalate that I discussed does, that leads to the formation of androgens, it increases the amount of glucocorticoids and influences the metabolism in the thyroid. Now, I haven't got a clue what the hell's going on there, but if you think of the complexity of that, you can see that some of these chemicals, while affecting our hormone responsiveness, will also, in an opposite way, affect some other aspect of hormones and the metabolism of whatever those hormones control, whether it might be thyroids or whether it might be glucose uptake and diabetes. I've been talking to Wayne Cupfield at the Liggins Institute recently about just this, because we're seeing a link between thyroid, a link between estrogenic compounds and diabetes. Terrible answer. And it's supposed to confuse you because it's an incredibly confused area that we really don't know very much about, except, my God, there's a connection.
There's an epidemic of thyroid disease in animals, in pets, in California, thought to be associated with brominated flame retardant exposure.
Well,
these animals spend a lot of time on your couch.
Yeah, it's a very good point, this. And in fact, I didn't mention, I've got to come and see you, Barbara.
Oh, no, I want to come see. I'm so sorry I'm not there. Come see me.
You are really very
it's
good.
Summer
And
now.
I'm beginning to, I'm falling in love with you here because...
Yes, yes.
No, me too. And you'll also
Well,
fall in love with this young toxicologist who's also working with me. And the more toxicologists, the better.
Fantastic, because what you're doing is so aligned to what I'm interested in, and you're a long way ahead. So we need to talk on the phone soon.
If
We actually we're initiating a project on thyroid cancer. There's also an individual who's looking at thyroid hormone as an intermediary for some of the growth and development effects of in utero exposure. So we're also we're resubmitting a grant to look at these chemicals as obesogens, as actually metabolic disruptors. So I think these effects are real. We have some interesting preliminary data also on the perfluorinated compounds.
But if you look at those,
there's a lot.
the brominated compounds that are used as
the flame retardants, but also
flame
the perfluorinated, the PFCs also.
The studies that Kate Hill has done, quite interesting. She's shown if the cats sleep in hammocks, which is what you're talking about, Barbara, they've got a greater chance of thyroid problems. And if you take the polybrominated biphenyls, which are the things that are fire retardants, and draw in my ChemDraw structures, and you can superimpose the thyroid hormone on them absolutely perfectly. I don't know whether anyone's ever done that before, but this is a perfect link. I'm sure that's why it's happening.
Scientists.
Yeah, we're worried. Everyone's very worried.
Getting it on.
California has the highest use of those in the world, I believe.
Does it? Well,
because we promulgated legislation to protect people from cigarettes in furniture. Yeah.
Do we have a non-scientist question?
I'm really pleased that you two just did that, in front of us all.
I know.
It's getting some good science going here. You've achieved your goal.
As a thyroid, as a breast cancer survivor who no longer has a thyroid, I actually found it very interesting. With a very limited understanding of what you were talking about, but sorry, this is not the part of the question, but circumstantially, I know a lot of women who have both had breast cancer and have had thyroid problems. And I've followed it up with my endocrinologist, and he says that there's only one very, very small connection somewhere, but my circumstantial experience would actually indicate that there's something there that's going on that is not actually in the science yet. Because I know too many women who've either lost their thyroids or are having treatment for thyroid malfunctions. And I think Kate's
cats are telling us that story, actually.
Right. Well, there you go. Sorry, I want to go back to the DDT thing, Ian, because I have a memory as a child, and I'm sorry, I'm now 53. I was diagnosed at 43. So I was born in 1959. And I grew up in the Waikato in Hamilton, on the very edge of Hamilton, which is very close to, we used to visit dairy farms every year at our school. And I have a memory about DDT being used in that period, which would actually correlate with what Barbara's been telling us, I think. And obviously it's the question we all ask ourselves when we get diagnosed is, how the hell did I get this thing? And I remember reading some stuff about DDT at the time, and a possible connection between the two, between breast cancer and DDT. And I was just wondering, are you able to give any more information about how it was used in New Zealand, how it was applied to farms?
Yeah, I can. Yeah, it was applied in two main ways. The first was spraying it, and the second was as a powder. Right. And I didn't know about the powder until just the other day, actually. But some of it was applied as a powder, so it could be inhaled, which is what I was interested in, which is why I found out the question.
You want me to go?
Yes, Violet, do you have a question?
Talking about penises.
Oh,
as we were.
Barbara, have you... Yes.
So how large is that crocodile's penis to where it is today? It's big butt, Mama?
That's a very good question.
To where it is today, skinny and elongated?
In fact, Barbara might know Louis Guillette at Florida, who did the work on alligators' penises. He's a great guy. I talked to him at a meeting once, and he told me how he did this with his PhD students, going out on these little sort of hovercraft things and catching the alligators and measuring the length of their penises. And sadly, it's not as amazing as you think it is, because in fact he was measuring the ratio of one bit of the penis to another bit of the penis, and the ratio changes, and that ratio is indicative of changes in the development of the penis. So it's not as obvious as it might sound. So the actual penis is really quite small. I was surprised, but the length doesn't change tremendously. It's the ratio that changes, and that ratio is linked to differences in testosterone in the alligators.
Kia ora, Violet, thank you. Sue, you have a question?
I'd just like to go back to the iodine issue, because like Deirdre said, I've come across a number of women who've had breast cancer and thyroid cancer or thyroid issues. And I wrote an article for Upfront a couple of years ago now about the link between iodine deficiency and breast cancer, because iodine deficiency is associated with fibrocystic breast disease, which is a risk factor for breast cancer. Iodine deficiency is also associated with fibroids, uterine fibroids. And in fact, I was told by Dr Paul Butler a couple of years ago that they used to actually paint the inside of women's uteruses with iodine as a treatment for fibroids. Okay. And I just find it really interesting, this interconnection. And obviously, I mean, I don't expect anyone to actually come up with an answer, but it seems to me there is this complex interplay between iodine, thyroid, estrogen, breast cancer, uterine fibroids, and I just wondered if any of you had any particular comment, and given, in light of the known iodine deficiency in New Zealand and increasing breast cancer incidence, whether that is something that really needs more research.
I mean, to kick off, the two ladies are going to know more about this than me, but the interrelationship between hormones is amazing. So if you've got a low level of iodine, then your thyroid is going to be trying to work overtime to capture more iodine and manufacture thyroxine. And so thyroid-stimulating hormone, which is a really important hormone, increases in concentrations. And when thyroid-stimulating hormone increases, it changes the ratio of synthesis of all of the hormones in that big pathway I showed you earlier, which could lead to changes in estrogen levels, changes in androgen levels. The complexity of all those interactions is enormous. And it's often very easy to show links between one hormone effect and another hormone effect because of those interrelationships. But Charlotte, you probably know more.
Can I interrupt?
We're on fire.
We do have a fire drill in progress. I'm sorry, Barbara, we probably won't be able to return, but can I actually urge everyone to vacate the building, please?
Go home for your gin and tonic, Barbara.
Kia ora, Barbara.
Yes.
And I can't linger, but the applause is yours.